Okay, this is question 7 on the part B, second part where you could use the graphing calculator. Oh, I didn't finish writing the problem, but I got minus 2 over x plus 5. So again, this is subtraction. So what we want is to make sure they have a common denominator. And so we're looking for an LCD. And that would involve what we're going to need to do is factor this right here. Okay, so when I factor that, that's going to give me factors of 10 that subtract to 3. Looks like 5 and 2. Okay, and I want more, but they have to subtract, so one has to be positive and negative. I want more positives in the middle, the plus 3x. So I'm going to put in minus here. Okay, so that's what I needed factored as. So now if we look at the bottom of this, and we say, do they have anything in common? Yeah, they have an x plus 5. So we just need one x plus 5. Some of you are putting both of them down. You only need one of them in this case. Okay, 1x plus 5. Now this other factor in yellow, this other term in yellow, one of the other factors in the denominator is x minus 2. So I want both fractions to have an x plus 5 and an x minus 2. Which means this one here doesn't need anything extra. It's already got it. I don't need to do anything to that denominator. So I'm going to rewrite that down. The only thing I'm going to do is write it as 3 minus 4x over, I'm just going to write it as if it was factored. But when I look at this one here, it doesn't have this in it. So I'm going to need to do that to top and bottom. So I'm going to multiply the bottom by x minus 2. So now it looks like the LCD. That means that whatever you do to the bottom, you have to do to the top. So it's going to be minus 2. Okay? Like that. So when we do that, we're going to get... Now be careful here. This is where a lot of people went bad. This minus 2 has to go inside to both of those. So if you want to make this plus, then you're going to have a negative 2x and a plus 4. That's a critical mistake people made. And on the bottom you have x plus 5, x minus 2. So what I did in purple there was make sure I didn't forget the negative before I distributed. It's negative 2 times x and negative 2 times negative 2, which is 4. Now when we look at these, they have the exact same denominator, so I can add numerators. So my final answer is going to have x minus 2, x plus 5 in the bottom. And in the top I'm going to have, let's go and start adding. 3 constant with 4 constant is 7, and it's a positive. And then negative 4 x's plus negative 2 x's is negative 6 x's. And that doesn't factor anymore. You can try to factor the negative out, but it won't change anything to look like the bottom, so we're done. Okay, so this is number 10. I skipped a couple here so I could keep all the stuff that's going with section 8.6 together. So the last problem I did was, actually, not 8.6. I think I want to do is 8.5, and 8.5 would be looking at this other complex fraction. So put this on hold here. So sorry about that, I was trying to do the wrong problem. So I'm going back to number 9 here. So it says simplify the complex fraction. Again, there's no equal signs in this problem. Don't try to force it to equal anything. We're just going to try to make it simpler. And one of the ways is to look at factoring as much as you can down, to look at what common denominators have, and then only using those common parts once. So let's look at this part right here. If you were to factor that, I can take a 2 out. Now it looks like x squared plus 2x plus 1. And it turns out if I look at that, that is 2 times x plus 1 times x plus 1 which is x plus 1 squared. It doesn't look that neat, so I'll rewrite that. Okay, so that's what the denominator of the denominator looks like. Okay, what else is in the denominators? Well, in the numerator, there's this denominator and there's this denominator. Are any of them the same as the bottom? So let's compare these bottoms. Okay, some people want to jump and do stuff, and it's like, just wait. Let's see what the LCD is, and that will save us time. Well, it turns out everything is the same. There's no extra stuff. It's just sometimes you need more of one than the other. So, if I look at that, the LCD is going to be, now, when we do this, anything that's written twice only gets written once. So, we have a 2 and a 2. So let's write a 2 down. Okay? We have an x plus 1 and we have an x plus 1 and an x plus 1. So we get 1x plus 1. Oh man, I'm having trouble writing. And then we're still left on the bottom here with another x plus 1. So I need another x plus 1. So in other words, I've found a 2 for that one. I found, if I rewrote this as x plus 1 instead of x plus 1 squared, this one and this top one right here go together. And then this extra one down here needs to be found a partner. It has no partner, so it just goes to the dance by itself. So it's right here. Okay? So we're going to need to multiply top and bottom by this super LCD, if you like. Okay, we're going to multiply the top and bottom fractions. So we're going to make sure you realize there's a big fraction bar here, separating the top and bottom fractions. So the top one I'm going to multiply by 2x plus 1, and to save time, I'm going to write it squared. Okay? Same thing on the bottom. 2x plus 1 squared. And I'm going to multiply, and when I do the top, it's a little trickier because I got to take this whole thing, multiply by in here and in here. And this one's not as tricky because it's going to go inside times the 3. Okay? So when I do that, this is what it's going to look like. It's going to be 2x plus 1 squared over x plus 1, that's the top, plus another 2x plus 1 squared over 2. That's the numerator. And then the bottom is going to be 3 times 2 x plus 1 squared over, remember what the bottom became? Became this. So I'm going to write this on the bottom. 2x plus 1 squared. So you're saying, well, big deal, the bottom, it looks really easy. Yes, the bottom looks great. 2 cancels out 2, x plus 1 squared cancels out x plus 1 squared. Yay. What happens? So we're only left with a 3. So that makes our life really easy. The bottom will be over 3. The top, let's go again. We got an x plus 1 to cancel out an x plus 1. So then we're going to have to go 2 times x and 2 times 1. So 2 times x is 2x plus 2. Let's look at the bottom on the other side and the top of the other side. 2 cancels out 2, and I'm just left with this on top. But I already know what that is. That was written right here. I'll do a different color. This is a binomial squared, and we'd already factored it out anyways. X squared plus 2x plus 1 because we had factored it. So we already know what that is. So I'm going to write that right here. And it's a positive in front, so no sign changes. So it's going to be plus x squared plus 2x plus 1. That's what that became. So let's combine like terms and simplify and all that kind of stuff. So we're going to get, let's look at our x squareds. X squareds are here, there's only one. Then we're going to have 2x and 2x is 4x, both positive, so it's 4x. And the last part, we get a 2 and a 1, that's plus 1 over 3. And that's really, you're done the problem. If you wanted to, you could factor it. Turns out they're not going to help you cancel anything else. Actually, you don't factor that. That's done. I think I added wrong. That's a 3 here. This is a 3 here. You can factor that. So you're going to get x plus 1, x plus 3 over 3. It still doesn't help you anyway, but you can see it out there. And then we're done. So that was number 7, and then I turned to number 9.